Hello, and welcome to the section on relations and functions, which is a part of my favorite chapter on linear functions and graphing. But before we get into anything, we need to review a couple things. Remember this? It's called a coordinate plane, and we use it to graph points or coordinates that look like this. Remember that your first point is your x-coordinate, and your second point is your y-coordinate. Similarly, we have an x-axis, this one, horizontal, and we have a y-axis, which is this long one. I tend to think of it or remember it in this way. Y has this long line, right, that kind of looks like the long vertical line of the y-axis. And then you just remember that the x-axis is the other one. Now, if we were to graph this, we would first look at our x-point, which is 1. And so all we would do is count over 1 on our x-axis. And then we'd look at our y-point, which is 2. So along the y-axis, which goes up and down, we would count up 2. Therefore, our point is right here. So we're familiar with the coordinate plane and we're familiar with how to graph x and y points. But let's graph another example just to be sure. Let's graph the point 4, 5. So remember the first point is our x, and we can remember that because x comes first in the alphabet before y. And our second point, which is 5, is our y point. So if we are going to graph 4, then on the x-axis right here, we are going to count over 4. 1, 2, 3, 4. And then we are going to count up 5 along the y-axis, which remember is the tall one. So counting up 5 is right here. And so our point 4, 5 lies right here. Okay, so let's look at these points 1, 2, and 4, 5. So if we were to label our x points, we'd probably want to label it something like this, right? Because our x points are 1 and 4 because they're the first numbers in the pair, and then our y is 2 and 5 because they're the second numbers. So if we wanted to write them out in a little different way, we could write our x points are 1 and 4, and our y points are 2 and 5. And since we are fancy mathematicians, we are going to call them by their official names, which are domain and range. So our x-coordinates are our domain, and our y-coordinates are our range. Let's look at these pairs of numbers. We have 1, 2, 3, 4, 5, 6, 7, 8. So our x points are 1, 3, 5, and 7 because they're the first number in the pair, right? Because x comes before y. And our y points are 2, 4, 6, and 8. So how we could write them are our x points are 1, 3, 5, and 7. And our y points are 2, 4, 6, and 8. But because we're fancy mathematicians, we are going to write them in the technical way. So our domain is 1, 3, 5, and 7. And our range is 2, 4, 6, and 8. So again, remember that our x is just called our domain and our y is called our range, or vice versa. Domain is your x points and your range is your y points. So, what's your domain? That's right, your x points. And what's your range? That's right, your y points. Now let's apply the graphs. So here we have Steph Curry's 3-pointers by his age. And even though you don't see an X and a Y axis, there is one there. Remember, our Y axis always goes up and down, and our X axis always goes across. So our X's are basically Steph's age, his points by age. And the Y, remember, always measures what's going up, is the 3-pointers that he's made. So we could say that at 21 he made just under 200, so maybe like 190. And at 22 he made, looks like in between 200 and 400, so let's just say 300, and so on and so forth. So if we were going to label our domain and our range, our domain would basically be Steph's age, and the range would be 3-pointers. And of course, we could write out the actual numbers, like domain is 21, 22, 23, so on and so forth. And the 3-pointers are 190, 300, so on and so forth. But I think we're getting the picture, right? Okay, so just to recap, we have reviewed where the x-axis is, where the y-axis is. We have reviewed how to graph points, use on the coordinate plane. We have learned that our x points are also called our domain, and our y points are also called our range. Now let's take things just a half step further. So we have these pairs of numbers, right? We have our x's and we have our y's, and these pairs are called ordered pairs because, as you can see, they are ordered first by the x point and then by the y point. So they're pairs. Remember, a pair means 2, so there's 2 numbers that are ordered, x and y. Okay. Think about different examples of pairs. We have pairs in the context of friends, and a pair like our parents, right? And think about whether we're talking about a pair of friends or a pair like our mom and dad. Each one of them has a relationship, right? We have relationships with our friends, right? A pair of people will have a certain kind of relationship, whether it's good or bad. In the same way, these ordered pairs also have relationships, and they are called a relation, right? And it's not super far off from the word relationship, right? We have relation and relation. So you can write a group of ordered pairs as a relation, or you can call a group of ordered pairs as a relation because a pair has some kind of relationship. And in the same way that we can have different kinds of relationships, for example, you can have a friendly relationship, you can have a romantic relationship, you can have a strong relationship, you can have a weak relationship, a bad relationship, a good relationship. You can have different kinds of relations in math also. And the kind of relation that we're going to talk about here is called a function, because some relationships function and some don't. So today we are going to see what kinds of relations in math function and which do not. Okay, so there's a party going on, and everyone's invited. And I'm like, where's my date? And then I see Josh coming to pick me up. But I also see that he's brought someone else with him, as in he is trying to take 2 dates to the party. And I'm like, no way, Jose. You take one or the other. Am I right? Well, we can think about these ordered pairs in the same way. Each pair of numbers has a special relationship, and together these ordered pairs are called a relation. But when one x tries to take two different y's to the party, then we have a problem. Let's take a look. So we have the ordered pairs 0, 1, 1, 2, 1, 3, and 2, 4. And we could write them out like this. Our domain is 0, 1, 1, 2, and our range is 1, 2, 3, 4. Or we could write them like this, with the 0 connecting to the 1 because it's taking 1 to the party, 2 connecting to 4 because it's taking 4 to the party, and then we have 1 connecting to 2 and 3. And as you can see, we have a problem. We have 1 trying to take 2 dates to the party. In other words, there are repeat x's. And what I mean by that is that we have a number in our domain or an x point that repeats. In this case, 1 repeats twice. And remember, there are no repeat x's allowed. And since 1 is trying to take 2 dates to the party, it's not a function, right? It's not a functional relationship. Let's look at this relation. We have the points 0, 1, 1, 3, 2, 2, and 3, 4. So if we list our domain is, remember, the first number. So 0, 1, 2, and 3. And if we list our range, remember the second number, or the y, we have 1, 3, 2, and 4. And we can see that there are no repeat x's, there are no repeat numbers in the domain, which we can also look at like this. If it's easier for you to see it this way, we have one output or one y point for every x. Basically, there are no repeat x's, no repeat numbers in the domain, which means that this is a function. Let's look at one more example. So we have the points 0, 1, 1, 2, 2, 2, and 3, 4. If we list out our domain, we have 0, 1, 2, and 3. And if we list out our range, we have 1, 2, 2, and 4. And remember, what is the rule to see if something or a pair is a function? Right, we have to look for repeat x's. So we look at our domain again, and we see no repeat points, right? Every number is there once. But you might be saying, hold on, how come we can have repeat y's? That's a great question. Think about it this way. Every input, or x, has to have one output, or y. Remember, in the first example we looked at, the x point 1 maps to two different numbers, 2 and 3. But it needs to choose, am I going with 2 or am I going with 3? In the example to the left over here, even though we have repeat y's, so 2 repeats twice, right? Still every number in the domain, or every x point, still has its own y. So in other words, basically, to sum this all up in a very easy, simple way, functions can have no repeat x's. She's even reminding you with her arms, no repeat x's. There's another way to see if a relation is a function or not. Let's say you're given a graph, but no exact points. there is a test called the vertical line test that you can use to see if the graph or the relation is a function. So what you do is you take something straight, like your pencil, and you run it over the graph and you see if it crosses the line more than twice. So for example, here the only place that the pencil is crossing the line is right here. Okay? And if we keep moving the pencil right along, we will see that again, the only place where the pencil is crossing the graph is right here. And if we keep going, we will see that it will only be touching the graph at one time. So you're like, okay, well then what would it look like if it crossed the graph more than twice? And that is a great question. Let's say your graph looked like this one on the right. If we take our pencil and run it over the graph, the pencil is touching the graph twice at every spot. So for example, here, the graph is touching here and here. And if we keep moving the pencil down, it's still crossing at more than 2 places. So if it only crosses one place, like this one, then it's a function. If it's crossing at more than one place, then it's not a function. Try these tonight on your own for homework, and don't forget to tell me why the relation is a function or why it is not a function. You got this.